So welcome to everyone to our virtual small satellite conference. This will be our webinar on ground stations, session 10. We have a number of panelists. I encourage you, let me quickly share the list of panelists that we have. I encourage you that if you haven't gone off and looked at the on-demand section of the small satellite website, that you do that. Their papers are out there. They have a full 15-minute presentation, all the details. Today, what we will be doing is we will be going through the presenters, our panelists, and letting them give a brief summary of their papers, and then take questions from our moderator and also from all of you out in the virtual world who've joined this webinar. I encourage you to look down at the bottom of your screen here in Zoom. There is a Q&A box. If you'll click on that and bring it up, you'll be able to type in questions. Feel free to type in and add your questions at any time. And eventually, as we move through the webinar, we'll get down to taking questions that are listed in the Q&A section and asking them of our panelists. You can ask questions directly to a specific panelist, or if you have something general for all of them, we would be interested in either of those kinds of questions. I would like to quickly introduce our moderator for our webinar today. Andrew Strange is an alum of the Small Satellite Conference and was a Frank J. Red Scholarship winner back in 2006. He spent his career working with satellite integrators and operators to solve challenging ground station problems through software. He's the Vice President of Waveform Products at Emergent Technologies, and he leads a very talented team of engineers who are changing the game for satellite ground communication systems. And at this point, I'm going to turn it over to Andrew, who's our moderator, and will conduct our webinar. Thank you all.
Thanks, Chuck. I'd like to start by introducing Brian Clofus, who's going to give us a short introduction on his paper from Planet Labs on merging diverse architecture for multi-mission support.
Yeah, hi, Andrew, thanks. My name is Brian Clofus from Planet Labs in San Francisco. This paper is about how Planet is merging the ground operations of our two constellations. A little bit of history. Planet was started in 2012 with our 3U CubeSat Earth observation constellation. We've launched over 350 CubeSats so far, with several more launches scheduled for this year. Originally, we built a network of mid-latitude ground sites to support our CubeSats that were launched from the ISS. And then we built several ground sites at high latitudes to support our SSO satellites. We now only have SSO CubeSats in orbit, so our mid-latitude sites have significant pass gaps during the day. In 2017, Planet bought the Skybox satellites from Google. Skybox had built their entire ground station network with KSAT at their high latitude sites. When the combined company kept the ground segments completely separate for the first 2 years. When the opportunity arose to launch the last 6 SkySats this year into a mid-latitude orbit, we decided that now was a great time to merge the ground networks. We had several mid-latitude sites from our earlier flocks, and we could use those for these new SkySats. The first 3 SkySats launched earlier this year on a Starlink launch. Due to the similar Earth observation missions of both the Flock constellation and the SkySat constellation, the satellites use the same frequency bands for uplink and downlink, which made combining the operations mostly a software endeavor. This paper talks about how we containerize the ground software to support multiple constellations on a single antenna. And that's it.
Thank you, Brian. In the paper, you talk and in the presentation a fair bit about one of the benefits of the approaches you've taken being higher utilization of your ground stations with fewer gaps in utilization. I'm curious if you can share any new challenges that arose from a scheduling or prioritization or otherwise perspective with that higher utilization, and any proactive tips to mitigate that.
Yeah, certainly. Our ground stations and the mid latitudes are certainly used a lot more now that we have 3 and very soon 6 SkySats in mid latitudes. So we have our SSO orbits, and that's like specifically at our Maddox site that is being used by our SSO constellation maybe 6 hours a day. And so the remaining 18 hours a day, there are no SSO satellites that are in view of that site. And so we're able to use the new mid-lat SkySats in that site. And that has significantly increased the utilization of that specific site. As for any pitfalls or ideas about this, I would just have to say modeling your orbits and all the precession that happens is very helpful. And it's, so, yeah.
Thanks, Brian. Next, Zach Lefke from Virginia Polytechnic was unable to join us to share about a prototype Virginia ground station network. So we'll jump ahead to Scott Scher from the NASA Near Earth Network to discuss NASA Near Earth Network, or NEN, DVB-S2 demonstration testing for enhancing higher data rates for CubeSat and or smallsat missions at X-band and Ka-band. Scott?
Hi, my name is Scott Scher. Can you hear me okay?
Yep.
Thank you. I am the Wild Flight Facility Manager for the Near Earth Network, NASA's Near Earth Network. Wild Flight Facility is on the eastern shore of Virginia. And the Near Earth Network is a collection of ground stations all around the world, supporting approximately 40 NASA, mostly NASA missions. And the antennas are mostly 11-meter class X-band and S-band receive and S-band transmit. Last year, the Near Earth Network did a study of S-band with DVB-S2 and found that DVB-S2 could enable 15 megabits per second, roughly 3 times the data rate in a 5 megahertz S-band channel, which is exciting. But it's even more exciting for X-band and K-band because what you'll see in the paper is that Yen Wang did some analysis, showed that you could achieve 1.2 gigabits per second over X-band and up to 10 gigabits per second over K-band with a reasonable CubeSat with a reasonable 2-watt transmitter and reasonable antennas, and with the Near Earth Network ground stations. So that's pretty exciting because typical data rates for X-band are only about in the hundreds of megabits, so it's almost a 10 times increase. And K-band, we do have some missions that will be 4 gigabits per second over K-band, but getting 10 gigabits per second is even better. And for CubeSats and small sats, high data rates means a lot for a network of ground stations, in that a higher data rate can enable a smaller number of minutes per day per spacecraft. And that could mean supporting a lot more spacecraft, constellations of spacecraft. It can also help with a mother-daughter situation where the mother CubeSat needs a higher data rate. And if you don't have a constellation, just having a high data rate helps collect more science. So please take a look at the paper and the presentation. Thank you very much.
Thank you, Scott. Can you talk to any plans upcoming or in the near future for on-orbit testing of any of these technologies through the Near Earth Network?
Well, DVB-S2 has been flown on a K-band spacecraft that was presented at this conference I think last year. And that's spoken about in our paper. It didn't use the New Earth Network, but it used one of our commercial providers. KSAT used a little, I think a 2.8 meter dish on the ground and CubeSat in low Earth orbit and achieved hundreds of megabits per second over K-band. And they have plans to go to higher data rates. As far as the Near Earth Network, we're looking for somebody to demonstrate on our network. We're talking with the University of Alaska. They have a CubeSat plan for a couple of years to fly it, and we're talking with radio vendors that may be interested in testing out a radio on the Near Earth Network on a CubeSat in the future.
Wonderful, thank you.
I
Next
did want
up-
to mention that
Go ahead.
EVPS2 has been around a while. It's a CCSDS standard. And we just don't have a lot of NASA missions using it today for whatever reason.
Yeah, it was great to read about that. Thank you. Next, we have Matthew Zerba from the University of Michigan talking about their paper, Expanding the Capability of Satellite Operations Using a Global Federated Ground Station Network. Matthew?
Hello, can you hear me okay? All
Yes.
right. My name is Matthew Zerba. I'm a graduate student from the University of Michigan in the state of Michigan, United States. And our paper was about using this idea called a federated ground station network, which has been around for a long time, and it's seen some attempts in the past, but we've been exploring this idea of using one to increase the capacity of small satellite operations. And recently, in 2014, a new attempt at this concept was founded. It's called SatNOGS, and it's become quite successful. There's a few hundred ground stations now, amateur ground stations spread around the world, and all connected to each other over the internet, and people that join up as part of the network can use them. And so at the laboratory that I work at school, the Michigan Exploration Laboratory, we fly some CubeSats. And one of the missions that we flew was called TBEX, or the Tandem Beacon Experiment. It was 2 3U satellites, or it is 2 3U satellites. And during the time that I was working on it, we tried out using SatNOGS to increase the amount of contact time and data rate that we could get down from our spacecraft. And so using this network in a very, not necessarily optimal way, but just where we were able to, we were actually able to increase the number of beacons that we retrieved in real time by over a factor of 2. 93% of those came from a collection of just 6 stations. And if you combine those 6 stations together and augment them with our ground station, our home ground station at the university, we expand the amount of weekly contact time with the spacecraft by a factor of around 10, depending on where in the procession you measure it. And so that's what our paper was about.
Thank you, Matthew. For those listening who may have an interest in, I'll say, duplicating some of the benefits that you observed from utilizing SatNOGS, what is involved with a mission sort of getting plugged into and making use of the SatNOGS network?
Yeah, so to begin with, in order to schedule observations on the SatNOGS network, you have to have set up a SatNOGS station yourself so that you're contributing back to the network. That's very easy to do. The software is all open source. The hardware that you need can be as simple as a Raspberry Pi computer to run the software itself. And then you can purchase some other amateur radio equipment costing only a few $100s, but obviously you can go a lot bigger than that if you want. And then there are instructions online in order to set it up. And so once you have a station up and running, you can schedule observations. And if your spacecraft is registered with, I think it's JSPOC now, with the identification number, which of course they all should be, then you can request LibreSpace to add your spacecraft to the network, and you can start tracking it from there.
Wonderful, thank you. Next, we have Toby Carman from the Defense Science and Technology Laboratory to speak about their paper, A Comparison of Fixed Threshold CFAR and CNN Ship Detection Methods for S-band Novastar Images. Toby, we're having trouble hearing you.
You're having trouble. Okay.
Much better.
Much better. Okay, it's probably my finger on the phone. Sorry. So I work at DSTL in the UK, which is the kind of the science and technology research arm of the MOD, and we conducted this work under the Space ISR program, and we wanted to investigate what could be done on kind of more of a budget, kind of more of like a small satellite type platform in terms of automated ship detection. There have been a lot of studies, a lot of research into what can be achieved using larger platforms like TerraSAR-X and that kind of thing. And we wanted to look at what methods would be applicable to S-band technology, and whether they're the same methods as seem to be more advantageous for X-band. And also further investigate the potential for AI to be used in remote sensing.
Thank you, Toby. Out of curiosity, what speed and/or performance of, for the SAR image processing did you observe comparatively between the two methods that were analyzed?
So it's interesting. So the AI sort of convolutional neural network method was quite well automated. So it really is just kind of feed in an image, and then roughly sort of 3 minutes later, you get your detections out. That they're not perfect. We're kind of working on it internally, but the CFAR method we found was more manual. It's not entirely automated yet. It required a certain amount of tuning with thresholds and that kind of a thing, which is why part of the reason why our test data set was fairly small in the end.
Great, thank you for that.
Thanks.
So that's the end of the introductions, and so we'll turn it over to some questions. Please send in any questions you may have, and I will direct them to the panelists. We'll start out with a question for Brian. Brian, do you have any plans for optical comm ground stations and/or MMW ground stations, or will S and X continue to meet Planet's future needs?
Yeah, that's actually a good question. We are always looking to increase the data rates of our, space to ground link. We were looking at LaserComm for a while, but we have kind of fallen back on Ka bands for our next constellation. So that's what we're planning on using for the next constellation we build. And so we're doing R&D right now. LaserComm is cool, but still the pointing requirements and the actual data throughput is still just not quite where we need it to be for even our current generation of X-band comms, which is, there's a paper last year in 2019, SmallSat 2019, about our current generation of X-band comms, which has all the gory details about that.
Great, thank you. Going back to Scott Scher, you mentioned and kind of alluded to some work, I believe it was with the University of Alaska. And I'm curious if you could expand a bit on what opportunities exist for educational institutions to work with the Near Earth Network.
Hi, well, that's a wonderful question. There are opportunities that NASA offers. I think it's called USIP, is a program that allows universities to bid on experiments, including CubeSats. I think it also includes sounder rockets, balloons, and aircraft missions. But universities can win that and then get an opportunity to be funded by NASA. And then we're exploring opening up the use of the Near Earth Network for those types of missions that are funded by NASA. Does that help?
That does, thank you. For Toby, question for you. You alluded to in the presentation and in the paper, future work that involved integrating AIS data into your ship detection using SAR. And it occurred to me, or made me curious, could that data be used to provide sort of additional training points, effectively live without having to go through manual training data generation? Has that been explored at all?
That's definitely something I want to look into. So it's called assisted labeling. It's not something that we've started looking into, but it's definitely sort of a topic of interest and has the potential to really kind of speed up that process. AIS data for Novoside during commissioning has been we haven't always been able to get access to it. But hopefully that's going to be changing soon, and we should have access to AIS in conjunction with the SAR images. Which should allow that option for us, and it's going to be really interesting to see whether that will allow us to potentially exceed sort of human levels of detection performance, because really we were ultimately limited in terms of training a computer by sort of how well we can even detect ships ourselves.
Yeah, I looked at some of the images, and I'm not sure I could do a very good job detecting some of those ships. Thank you, Toby. For Matthew from University of Michigan, a question came in: does the software for SatNogs tell you the quality of the signal on the network per station? And maybe just to expand on that, can you share what metrics are available? Signal metrics on a station-by-station basis.
So for this question, I am assuming you mean as a user of the network. So I should also probably, this question makes me think maybe I didn't differentiate enough between there's software that you install on your local computer if you are the owner of a station, and then there is software that runs remotely, managed by SatNogs, that you can access through a browser that you use if you're the user of somebody else's stations on the network. So to answer the question, there's not, as far as I'm aware, a lot in terms of live updates to signal quality. You can see waterfall plots of the spectrum after the pass is completed. You can see a waterfall plot that will be generated for you, and the stations have history of their rates of success and failures of detecting the spacecraft. But aside from that, not anything that I know of in terms of signal quality that's live.
Thank you. For Brian, we have a question for the Planet presentation. What container technology are you using? Is it Docker?
Yes, we're using Docker for all of our stuff. So, yeah.
I'll pile on. I'll just say any interesting challenges or advice as far as porting, your software that ran on dedicated hardware into the Docker containerized environment?
My only comment would be is to test and then test again. We had a kind of a date that we wanted to cut over everything by, and we spent a lot of time testing before that and uncovered a lot of bugs and squashed all the bugs, and then started running actually test stations that were fully containerized along with our existing network. And then when everything was looking good, after a couple weeks, then we fully switched over to the containerized deploy. At that point, one of the motivations for upgrading to a containerized system was for upgrading the underlying OS on all of our ground stations. Because once we'd built the entire software stack for, let's say Ubuntu, 12, when we started Planet, upgrading, to Ubuntu 16 and then Ubuntu 20 became kind of a dependency hell. And so we also switched into containerization to try and alleviate some of the dependency issues. So yeah, I guess my only advice is just to keep testing everything, and you'll figure out all the bugs and go from there.
Great, thank you. I'll kind of take this opportunity, Brian, since you're unmuted, to ask a question that I think we'll get answers from several folks on the panel, and I'll kind of work my way down, and we'll start with you. The question is, have you looked at using mesh networks within your spacecraft? Whether you have or haven't, I guess the question is, how far away do you feel the technology is to actually be, I'll say, usable in an operational capacity?
I don't think we've specifically looked at mesh networks either between our satellites or from the satellites to the ground. Our mission is to get satellite imagery of the Earth every single day, and our current network topology works really well for that. We have a lot of picture data coming down from the satellites every day. I think we're up to 8 terabytes per day currently, and that's coming down over X-band. And then it's got to get from the ground stations out to the internet and into the cloud. So we haven't really looked at mesh networks for that yet.
Would the same be true of crosslinks? Just so much data coming down that it doesn't really make the problem any more manageable?
We have looked into crosslinks a little bit. I know that there's been some talk about at past small sats about companies doing uplinks to GEO and then back down, or uplinks to TDRS and then back down. All of those data rates just aren't fast enough for what we need to do. So yeah, and crosslinks are the same thing. Crosslinks are cool, but we don't really want to be a crosslink company and spend a whole bunch of time and money going down the crosslink path, and we don't need to. We can just send the data straight down to Earth.
For sure. Another distraction, maybe.
Yeah.
To Matthew, do you have any, or I'll say any input on what the University of Michigan has looked at in regards to perhaps crosslinks and/or mesh networking?
So crosslinks like between satellites, do you mean?
Yes.
Yeah, so there have definitely been, the professor that I work for does research with some people that are interested in like swarms and constellations of spacecraft. And there's like similar work going on for drones as well. In terms of how that's related to the paper that I have worked on here, we haven't, specifically my team hasn't looked at that application for this network at the moment. But there is like research around the university about using satellite swarms and drone swarms.
Thank you. Toby, the question actually had a second piece to it I was saving for you. It specifically referenced the ability with crosslinks to perhaps utilize multiple SAR vehicles and/or tipping and queuing to improve results. Is that something that within your capacity at DSTL that you've looked into at all?
That's not something we've looked into, no.
Thank you. And last but not least, Scott, is the Near Earth Network involved in any or pursuing any experiments relating to mesh networking between spacecraft?
I don't know if you recall the mesh network, but the Near Earth Network is working with the TDRS or Space Network on something called user-initiated services, where the spacecraft links up with the ground stations as if they're a cell phone making a phone call, and it's all behind the scenes. You could use a space network to get real-time scheduling of a ground station for higher data rate transfers as they're going around, and ground stations come into view. They request services in real time, all done behind the scenes. I guess you could call that kind of like a mesh network.
Thank you. And while I have you, we had a follow-up question on the educational opportunities with NASA. The question was, does NASA offer these funding opportunities like CSLI to Canadian schools as well, or is it limited to US only?
I'm not an expert on that area. Be happy to get back to you on it. I just don't know. I saw that question come up and I don't know the answer right now.
Sure, thank you.
You're welcome.
Toby, we did have another question for you. In your presentation, do you feel CNN works better for X-band, aka with higher resolution or in general, than S-band SAR?
So we haven't done direct comparison between the two bands, but comparing our results with other results sort of in the literature, it's kind of hard to say. I would say that probably it will benefit from slightly higher resolution, but I've seen comparisons between different levels of resolution that indicate not a huge performance gap between sort of say 6 meter class and 1 meter class. I don't think it's a huge difference, and I think we've shown that a CNN approach is certainly applicable to S-band as well as X-band, but probably more work would be required to say so which band would be better or which approach would be better.
Sure, thank you. And back to Brian, this is, I think, a more general question. The question is, today S-band, VHF, UHF are all common bands that you see, CubeSats operating in. I think the question is, are there other options that, CubeSat missions, be they educational or startup, should be looking at in the near midterm that might be promising? Anything that that Planet is looking at from a band perspective that you could share?
Yeah, certainly. So I'm not sure there's much spectrum in VHF for commercial satellites. There's a little bit for amateur, but even then, that spectrum is pretty congested. Even UHF, I know there's been a big push recently from NOAA and the FCC to get commercial CubeSats and actually all satellites off of the UHF band right around 400 megahertz. And we are actually not going to get our UHF license renewed. Well, we have an expiration date on our UHF license, which is in 5 years or something like that, when NOAA wants us off these frequencies so they can communicate with their weather stations a little bit better. The other comment was S-band. Yeah, S-band's pretty good, although the bandwidth there is limited, and it's also pretty congested. And I think it's for uplink only. X-band is still pretty open. And then also you go higher, KA. KA band is open, although there's 5G pressure there also. So we're gonna have to see how that kind of shakes itself out in the next couple of years. For university CubeSats, I would still recommend UHF, for 37 megahertz. The SatNOGs network that was talked about has a lot of receivers there, and it's very easy and very cheap to build an amateur station at the university, and it's a good learning experience for all the students. And amateur satellites are just a lot of fun to talk through and learn on. So,
absolutely. Yeah. Question for Scott. Has NASA and specifically Near Earth Network done any testing with low cost, or I'll use the term consumer grade DVB-S2 cards versus I'll say dedicated, standalone hardware receivers?
So as far as our ground station equipment, to add DVB-S2 is just a license fee with our commercial off-the-shelf vendor that we use for our ground station equipment. For the University of Alaska flying DVB-S2 on their CubeSat, they're planning to use a little $1,500 S-band radio. And that same S-band radio is being flown on TechEdsat 10, which was just deployed from the International Space Station a couple of weeks ago. And that CubeSat plans to use that little radio to communicate with the Near Earth Network in the next week or so. And that's so that it's a pretty inexpensive radio. I think it's about $1,500. And then the DVB-S2 can be added with software by the university. In order to achieve higher data rates, they'll need to put it into a gate array, or a logic sequencer, and they're exploring that.
Okay.
I
Thank
do
you.
want to comment on the bands. Can I comment on that?
Yes, please do.
So the Near Earth Network has S-band, X-band, and K-band receive, and Near Earth Network does not have UHF, and the reason for that is because a NASA mission that uses UHF only gets it assigned as a secondary frequency. So if there's a pizza delivery truck, a police radio, or bridge construction workers using two-way radios, they could easily saturate out over a satellite signal hundreds of miles away, and then there's nothing that can be done about it. And so there have been cases where local interference has not enabled large UHF dishes to be used for CubeSats. And so S-band is a little bit crowded, but like I mentioned, that there's that $1,500 radio, which is kind of cool. And as you go up higher in frequency, you can get more bandwidth and higher data rates.
Thank you, Scott. A question for Matthew. Looking at your use of the SatNOGS network, it seemed primarily focused on, I'll say, additional beacon acquisition. And I'm just curious, as a admitted novice to the SatNOGS network myself, is uplink supported as well? Do you have plans, if so, to expand your use of the network to include that? And I have a follow-up, but I'll let you answer that first.
Sure. So to answer your question directly, uplinks through the SatNOGS network are not currently available. If they were, that would be something that we would consider, although there are security risks with doing this, especially depending on the security level of the software and of the signal being sent. For example, with the level of software, the level of security that we see with amateur satellites, they might be susceptible to things like replay attacks if somebody intercepts the transmission. And so things like that are something to consider, and something that the professor I work for also considers. And so considered, but we wouldn't expand into it immediately without some significant upgrades to our software.
Okay. And so within the context of your home ground station where you do uplink from, the question, and I'm summarizing a question from the audience as well, I guess would be, from a security perspective, what I'll say, what steps are you taking or have you taken to ensure security of the uplink to the spacecraft, and to also the question asked about potential jamming as well. So anything you can share on your approach there would be appreciated.
Sure thing. I'll have to admit, I don't have a lot of expertise in this area. I know the signals are encoded before they go up, but I don't know the algorithm about it. But I can answer about the jamming. We haven't had any experience with this done maliciously, but kind of to go off of what Scott was saying about accidental jamming from nearby UHF sources, our satellites use UHF, and so do the tracking beacons on the buses that run around campus. And they happen to be right near the same band, and they have been interfering with some of our downlinks. And so that's definitely a valid point. And you could probably use that maliciously as well.
Thank you, Matthew.
Mm-hmm.
For Brian, I'm curious, how do you have massive, relatively speaking, especially for small satellites, amounts of data coming down all the time. And you've talked to a virtualized, containerized environment via Docker. Have you had any challenges from a data ingress, egress, data at rest perspective, getting things from what was legacy or dedicated hardware into this more virtualized environment?
Not really. The hardware actually wasn't changed at all when we did the upgrades to containerization. So it's all, the server side is all COTS servers. We do have dedicated hardware receivers that do the DMOD from IF down into basically baseband frames at DVB-S2. And so that data flows in over an IP interface and gets stored locally and then gets uploaded to the internet. When you're talking about, let's say, 4 dishes at a particular site, and you're talking with, 4 satellites simultaneously, and each satellite is doing maybe a gigabit per second average, that actually adds up to quite a lot of data that is getting stored locally and then has to get up to the uploaded into the cloud. And so, finding fast internet pipes out at these remote locations is sometimes pretty difficult and or very expensive. So that's been the biggest issue, is making sure that the internet connectivity is up, and then, the power goes out somewhere along the line and the fiber gets, cut by something, and, the site goes down for a couple days. So.
Thank you for that. Question for Scott. The question is, the results, I think, for or the experimental results for the predicted data rates presented in the paper, I believe, were forthcoming and delayed by COVID. Where can people find those results when they do become available?
They can contact me. They can send me an email. I'll be happy to send the result.
Great. So those will be, those are releasable and available generally.
Yes, they are.
Thank you. Question for Matthew again. I wonder if you can talk to your approach to, I'll say, scheduling on the SatNOGS network. There was some talk in the paper and the presentation to kind of being good citizens of the network and being a bit of a, I'll say, a certain amount of trust that kind of is implicit in being a part of the network. Can you talk to any of University of Michigan's experiences with that, any challenges that were experienced, and any suggestions to those who may wish to use the SatNOGS network going forward?
Sure thing. So for those who don't know, when you schedule observations on SatNOGS, you get a window for the next 48 hours that you can select ground stations within. You set the spacecraft that you're interested in observing, and it looks at all the space or all the ground stations that have the right radio equipment and are in the right locations, and then you can pick out the ones that you want to schedule. And so that 48 hours, I'm not sure where it comes from. It's either from that they don't want you to schedule things too far out in advance because the TLEs will go out of date, or it's because they don't want people scheduling too many things. And the too many things is kind of more of the core of this question. And so you can go in there and click all of the observations, and it doesn't look like it will stop you. If you try to press it, it will say like, warning, you're about to schedule like 200 observations. Do you want to do this? And we didn't try it, but it looks like it would just let you in. And so it's very open, and you kind of have to trust that somebody else won't drown you out. We haven't experienced any difficulties with this, just because the the network has grown so fast and the demand for bandwidth on the network is still low, very clearly much lower than the supply of the network bandwidth. But in the coming years, that might change. And we talked about in our paper some ideas about maybe things that we could do about this, either like first come first serve allocation, or based on how much you contribute back to the network, or something like this.
Thanks, Matthew. Toby, for those of us who are not image processing or SAR experts in the audience, I'm curious, are there any things about the convolutional neural network algorithm that you've evaluated that would have application, I'll say, to nearby use cases? So either traditional imagery or detection of perhaps objects that aren't ships. Is there any application of those approaches outside of the field of ship detection with SAR?
Yeah, for sure. Yeah, neural networks are really becoming much more popular for general image or object detection, I suppose, and object classification applications. So really, in any image, you can pretty much train a neural network to detect stuff. So there's a lot of research on that, and the approach that we took is really completely general, and you could have used it on, you know, drone photography or optical imagery or almost anything.
Thank you. Brian, one more admittedly softball for you, having seen some previous Planet presentations, but I wonder if you could elaborate a bit. It's mentioned in your paper, but on the role of automation in enabling, I'll say, higher utilization of your ground stations.
Well, certainly, you know, we've got, I don't know, maybe 120 or so CubeSats that are, you know, taking images right now, and then the 16 or 18 SkySats. You can't schedule those number of satellites manually at all. So everything's automated. All the, you know, past predictions and scheduling is all automated. Yeah, what was the question?
Just wondering if you could expand on I'll say the value of automation, but maybe more directly the technologies that Planet uses for automation within your ground network.
The technologies, I mean, we're using just the standard kind of web technologies. Most of the code is written in Python, and we're using, you know, all of the standard web technologies for passing data between mission control and the individual ground sites, individual ground stations. So, you know, the standard software stack, I guess.
Great. And one more question for Scott. In your use of the DVB-S2 standard, are you making use of adaptive or variable code modulation, ACM or VCM?
We think that VCM is a critical piece, particularly for take advantage of the higher link available at the higher elevations with the ground station and getting a lot more data down. And what's really cool about the demonstration that Yen did with S-band is he demonstrated VCM. And what's nice is that the receiver automatically detects the different modulation and different data rates. So there's no software automation or scheduling to be done. The spacecraft changes to take advantage of the link, and the receiver automatically detects it.
Thank you for that. So I think in closing, I'll give each of the panelists just a minute or two to share, if you would, what's on the horizon, what is next for you and your organization over the next 18 to 24 months? What can we look forward to hearing about next year? And we'll start with you, Brian.
The future. Well, we are launching a bunch more CubeSat, 3U CubeSats later this year. The Vega launch that's been delayed forever may finally happen later this month, hopefully. So we've got another 25 Super Doves or something on that. And then we are launching the final 3 SkySats on one of the next Starlink launches. I think it's Starlink 10, which I guess is still happening in the next couple of weeks or so. So that's what we're going from a satellite side. On the ground station side, I already mentioned higher frequencies, looking at KA, still looking at laser comm, and trying not to increase the number of sites because that's more capital costs and land costs and licensing costs and licensing delays when we go to new countries. So mostly higher frequencies and maybe not too many more sites.
Thanks, Brian. Scott, do you want to share what's next for you in the Near Earth Network as it relates to DVB-S2?
Well, not necessarily DVB-S2, but you open it up and say, well, what are we going to be talking about in the next year or two? And I did want to mention that $1,500 radio that TechEdSat 10 is flying and the University of Alaska is planning to fly. We're talking with a mission now that will launch with the Artemis 1 mission that will end up being 10 million kilometers from Earth, and they're exploring using the Near Earth Network with that inexpensive radio. And so that would be really exciting to get a signal 10 million kilometers away, many times the distance of the moon. And that particular mission, they will also be doing processing of the ground station signal in the cloud. So that seems to be a future direction of moving processing to the cloud. And they will also be demonstrating some innovative thrusters. So if that all comes about, we'll be potentially writing papers and presenting them at the conference about those technologies and this really long distance demonstration, and an alternative to very much more expensive long distance from Earth CubeSat radios.
Thanks, Scott. I hope to see you out in Logan to hear about that.
You're welcome.
Matthew.
Hi. So as far as research-related things go related to this topic, the laboratory that I work with has had a CubeSat in orbit now for over 5 years, which is a pretty long length of time. And an interesting thing about the CubeSats that we build is that our entire bus, for the most part, is built in-house, with the exception of some attitude actuators. And so it's interesting to this laboratory to see how our systems, hardware and software, have fared over time for that long of a period of time in space for an amateur satellite. And so part of the reason why we're so interested in getting all of these beacons down is because it allows us to data mine years and years worth of data from this one CubeSat that we've had up for a while, to see fault recovery methods that we worked on in the past in work for the last 5 years, and also get some data on things like the degradation of some of the hardware and power generation systems. And so that's a kind of a big thing on the horizon related to this topic for this lab.
Very interesting. Thank you.
Yeah.
And Toby, if you could finish us out.
Hi, yeah. So I guess more in the short term, we're hoping to start to use our tools a little bit more operationally in like a sort of R&D sense. Hoping to contribute to some ongoing sort of international collaboration that's coming up very soon. Also, I mean, in other news on the DSTL front, we're looking forward to hopefully the launch of the Circe mission either later this year or next year. I'm not sure what the date is now, which will be very exciting, and we'll be hopefully controlling that from the ground station based here in Portsmouth in the UK. So that's really sort of exciting, and real kind of new capability for UK space S&T.
Very exciting. We'll look forward to that. So with that, I want to thank everyone for joining us today. A big thank you to all of the panelists for sharing your thoughts with all of us. And I'll turn it back over to Chuck.
Okay, thank you. This has been a wonderful webinar. We've had a lot of really excellent papers. Want to thank all our webinar panelists. You know, I can hear everyone clapping. Let's all give them a round of applause if it were possible for an excellent set of papers that they presented here at the conference and for their webinar responses. Personally, I'm just amazed at the increase over the years that I've seen in the small satellite community and the sophistication of ground stations and communications with small satellites and particularly CubeSats. It's just amazing what is possible today. And with that, we'd like to thank Andrew for conducting a wonderful session. Thank you very much. And we are done with our webinars for today at our virtual small satellite conference. And we'll see you tomorrow. Thank you all.